And here, if you look at what you got, okay, take a look. It says in a forensics lab, a reaction is observed, with delta G equaling that number and the standard delta G equaling that number at 298 Kelvin. What is the reaction quotient Q? So if you look here, you're going to use this formula right there. So you're going to use this formula right here. So I'm just going to go ahead and delete the first one because we don't need that one. And I'm going to delete this one because we surely don't need that one either. Okay. So since you're going to have the natural log of Q, okay, equals your delta G minus your standard delta G divided by R times T, you're going to plug those numbers in right there, okay? So this is your formula that you're going to use right here. This is the formula that you're going to use, okay? So let's go ahead and use those numbers now. Let's plug in our numbers. So the natural log of Q equals your delta G was negative 4.5 kilojoules per mole minus, now because that's a negative sign and then you have a negative sign here, you're going to say plus 6.0 kilojoules per mole divided by your gas constant 8.314 joules per mole dot Kelvin. And guys, again, we're going to deal with the kilojoules in a minute. I like to set it up this way, okay, so that you all are able to see that whatever you get on the very top right here, you're then going to multiply it times 1,000, okay? So set it up first, then multiply it times 1,000 to get it into your joules, okay? So you're going to multiply that times 1,000 in order to get your answer into kilojoules. So that's going to be negative 4.5 plus 6, okay, which is basically equal to 2.5. But in case some of you all, yeah, sometimes you'll have to find delta G, yes, and you can use that formula as well. So they have a formula for each of them, okay? They have formulas for each of them. So you get 1.5 times 1,000, okay? And that's equal to 1,500. So natural log of Q equals to 1,500. Now, I'm not going to, well, yeah, let me include it because I don't want to shortcut y'all. That's joules per mole, okay, divided by. So let's go ahead and take this number right here, okay? You've got 8.314 times 298, which is 2478. Okay, we're just going to round it off to 2478. Joules per mole, okay? And all you have to know now, of course, you're left with Kelvin here. You know your joules per mole cancels out. Now, here is the thing. Because you're trying to find the natural Q of that, you're going to have to say E to whatever this is equal to right here. So when we say 1,500 divided by 2478, you get 0.605, okay? So when you plug this into your calculator, you will end up with your answer. So let me go ahead and pull this up here so you all can see that, okay? Right there. And of course, you all know, oh, and the Kelvins also canceled out. So I don't know. Yeah, I forgot to slash that off too, y'all. See that? The Kelvins also canceled out. So that's what I should have represented. Because you're going to have a unitless answer. Okay? Yep, you will use E to that. Yes, E to that. So I'm plugging it into my calculator here as well. I get 1.83. Letter A as the answer. Now, if you would have plugged in, if you would have said, okay, I'm going to show y'all this yet where y'all can see this, okay? If you would have said the natural log, like hitting this key right here, 0.605, if you would have pressed that key right there, you would have gotten 0.502, but neither of those answers has 0.502. If you look behind that key though, you see that little EX? You have to use that number instead. So 0.605, okay? Shift on my calculator, eats right there, natural log, gives you that 1.83, all right? So letter A is the answer. Just remember, if they give you kilojoules per mole, do the math first for kilojoules per mole, then multiply it times 1,000. Because if you do them individually, that's just double the work. Get the sum of that or the difference of that first, then multiply it times 1,000. That way you're able to kind of like do them together rather than individually and forgetting some of the steps. Okay. An investigator is checking the concentration of a precursor chemical. At 298 Kelvin, delta G is equal to negative 10.0 kilojoules per mole. Standard delta G versus the delta G is equal to negative 12.0. For those of you all that don't know, why do they give you one that's standard? What it should be versus what it is. That's what that represents. What it should be versus what it is. Okay, that's pretty much what that represents. So now I know that that's the natural log of Q is going to equal to your negative 12.0, okay, kilojoules per mole minus negative 10. So that becomes a positive 10.0 kilojoules per mole divided by 8.314 joules per mole dot Kelvin times 298 Kelvin. Now, remember, you got negative 12 plus 10, so that's going to equal to negative 2.0. Okay, so you've got negative 2. Now remember, negative 2.0 times 1,000, that's going to give you 2,000. Okay, negative 2,000. Because remember, you get this answer first and then multiply it times 1,000. If you decide to convert, well, okay. I'll show you that answer so that way you can see what the difference is. Okay, yeah, I'll show you that answer so that way you'll know what the difference is. So right here, you've got negative 2,000 joules per mole. And you already know on the very bottom, the joules per mole and the kelvins are going to cancel out. And the joules per mole is going to also cancel out, okay? And let's go ahead and multiply that. 8.314 times 298. We get 2478. Okay, again, your joules per mole gets canceled out, okay? Now, let's go ahead and divide the 2,000 divided by 2478, and you get 0.807. Okay. Remember, that's negative, okay? That number was negative. So you've got 0.807 negative though. and I get 0.446. Letter A. Letter A. So again, right here, you had to say e to the negative 0.807. And again, let me show it to you so that way you all can see. I've got 0.807. Now let's say that you didn't put it in negative because it is, right? Shift natural log. You see that 2.24? That's going to give you an answer here, but that's not correct. You have to make sure that you look at that negative sign. That negative sign is 0.807 negative. See that? Shift natural log. And so it's the antilog of that. And you end up with 0.446, letter A, which is the correct answer and not the 2.24. By not using the negative sign, you get a completely different answer. Now, let's say that someone, again, they did not convert the kilojoules, okay? So if you got the negative 12 plus 10, which you're going to get 2, right? Then you divide that by 8.314, divide that again by 298, okay? You end up with a very small number, negative 8.07 times 10 to the negative 4. Now, you're going to take the antilog of that, shift, and you see that 0.999? There's that answer right there. If you did not convert this answer, okay? And that's why you end up getting the wrong answers when we don't do what? Convert. So this is why we have to convert the answers in order to make sure that we're on the right track, okay? All right.